This is a selection of factual recall questions for the AS chemistry topic of oxidation, reduction and redox. The questions are linked to in the description below so that you can try answering them and then check your answers. As you know from GCSE, oxidation can be defined as the loss of electrons, whereas reduction is the gain of electrons. By using oxidation states, we can look at these numbers to work out whether a species has been oxidised or reduced. If the oxidation number gets less positive or more negative or just smaller, then we can say that this has been reduced. Whereas if the oxidation state becomes more positive, then the species has been oxidised. Spectator ions are ions that we find there in a redox reaction which aren't actually part of the change in oxidation state. So if you find a species whose oxidation state hasn't changed, then it's a spectator ion. An oxidizing agent is something that causes another species to be oxidized. In other words, it causes that species to lose electrons. Likewise, a reducing agent is going to be itself oxidized. It's going to cause another species to be reduced by causing that species to gain electrons. A redox reaction is one in which both reduction and oxidation take place. Disproportionation is something that happens when one species undergoes oxidation and reduction at the same time. This will of course mean that two different products are produced. So for instance, if we think about the breakdown of hydrogen peroxide, this is a nice example of this. It breaks down to form water and also oxygen. In the hydrogen peroxide, the oxygen has an oxidation state of -1. In the water, it's the more common oxidation state for oxygen of -2, and of course in elemental oxygen, because it's an element, it has an oxidation state of 0. So the oxygen has both been reduced and also been oxidized. An oxidation state is just a number that we apply to a species in order to indicate whether from its elemental form it's gained or lost electrons. The oxidation state for an uncombined element is always 0, and the oxidation state for a group 1 metal is always +1. If we're thinking about transition metals in a compound, then the Roman numerals indicate to us what the oxidation state is. So for instance, if I have iron 3 oxide, that tells us that the oxidation state of the iron is going to be +3. In any compound, fluorine has an oxidation state of -1. It's the most electronegative element and therefore everything else defers to fluorine. Chlorine also usually has an oxidation state of -1, which is what we see in hydrogen chloride, but when chlorine bonds to fluorine, because fluorine is the most electronegative, it kind of wins and stays as -1, and therefore chlorine must be +1. Likewise, when chlorine bonds with oxygen, oxygen is again more electronegative, so chlorine defers to oxygen. So that means that it ends up with an oxidation state of +5. So if we think about this, the oxygen has an oxidation state of -2, and there are 3 of them, so that makes -6 in total. And if we compare that to the overall charge of a single minus, then what we're missing is the +5 that comes from the chlorine. In most compounds, oxygen has an oxidation state of -2, so as in water, but in peroxides, where we've got this single covalent bond between the 2 oxygen atoms, then we see an oxidation state of -1 instead. Likewise, for hydrogen, we have a normal rule and an exceptional rule. So the normal rule is that hydrogen will be +1, which is what it is in water. But where we find hydrogen in a metal hydride, so it's acting as the anion rather than the cation, then we're going to see it having an oxidation state of -1. If we've got a neutral compound or a polyatomic ion, then we know that all of the oxidation states are going to add up to either be 0 if it's a neutral compound, or to be the charge of that polyatomic ion. In order to deduce the oxidation state of one element, we can use the oxidation states of the other elements that we know about. So if we think about potassium manganate, then to start with, we know that oxygen is going to be -2 because this isn't a peroxide, and so we just go to the standard -2. There are 4 of those oxygens, so that makes a total of -8. Then potassium is in group 1, so we know it will have an oxidation state of +1, so we can factor that in. And because this compound is a neutral uncharged compound, overall we know that all the oxidation states must add up to be 0, and therefore what are we missing? +7. So that will be the oxidation state of the manganese. My first step in assembling this half equation is to balance the species that's being reduced or oxidised, which here is the chromium. So on the left-hand side in the chromate ion I have 2 chromium atoms, but on the right-hand side in this monatomic ion I currently only have 1. So firstly that needs balancing. Then I need to look at the changes in oxidation state. So firstly I'm going to need to work out what the oxidation state of the chromium in the chromate ion is. Oxygen we know is going to have a -2 oxidation state, and there are 7 oxygen atoms. So that makes a total of -14. Now I know that all of the oxidation states together must add up to make -2 because I've got a 2- charge on this polyatomic ion. So in order to get to -2 from -14, I need to add 12. But that's split between 2 chromium atoms, remember. So each one is going to have an oxidation state of +6. In the monatomic ion, that's obviously much more straightforward. It's a 3+ ion, so the oxidation state is +3. So to get from +6 to +3, I need to go down by 3. But I can't subtract positive charge, I can only add negative charge. So each chromium atom requires the addition of 3 electrons for those 3 negative charges, and there are 2 atoms, so that's 6 electrons in total. Then I need to look at the oxygen. So on the left hand side I've got 7 oxygen atoms, and the only way that I can add oxygen is by adding water. So I'm going to need to add 7 water molecules on the right hand side. And then finally I need to add hydrogen ions in order to balance out that. So I have 2 hydrogens per water molecule, 7 molecules in total, so that's 14 hydrogen ions. And that's my completed half equation. Finally, we look at combining half equations. So here I've been given 2 half equations, one for chlorine turning into chloride ions and one for manganate ions being turned into manganese ions. And in the question it tells me that potassium permanganate is reacting with hydrogen chloride. So the first thing that I'm going to need to do is to flip one of these equations over. So I can see that currently they both have electrons on the left hand side, which isn't going to work because it means that 2 species are being reduced, and also the question tells me that we're reacting with hydrogen chloride, not with chlorine. So this first equation is going to need to be flipped over and rewritten the other way around as an oxidation, not as a reduction. Then the next thing is that my electrons need to balance. So in this first equation I have 2 electrons, but in the second one I have 5, and I need the same number in both. So I need to look for the lowest common multiple of 2 and 5, which of course is 10, and then I need to multiply up accordingly. So for this first equation I'm going to multiply everything by 5, and for the second one I'm going to multiply everything by 2. So now I can start putting these together. So I've got 10 chloride ions from my 5 sets of that first equation, and 2 manganate ions from that 2 lots of that second equation, and also we're going to have 16 hydrogen and 10 electrons there, and that's going to react to form 5 chlorine molecules, 10 electrons, 2 manganese ions and 8 water molecules. And then because I have the same number of electrons on the left and the right, then I can just take those out because they balance out, and that's my completed equation. Thank you very much for watching, and I hope you found this a useful contribution to your revision for A-level chemistry. If you did find it useful, then let me know in the comments below, and don't forget to like and subscribe for more A-level chemistry resources coming soon.